Hello, today we are going to do lesson 2.7, which is finding square roots and then comparing real numbers. We're going to focus more on square roots and our perfect squares today. So we're going to start off with our perfect squares. What we mean by a perfect square is a number that's multiplied by itself, like 3 times 3. Both sides of a square are the same, that's why we call it a perfect square. 3 times 3 is going to give us 9. So we are going to list all the perfect squares, like 1 times 1, 2 times 2, 3 times 3, 4 times 4, all the way up to 225. That seems like a lot, but where I'm saying up to 225, this is 9. So we're going to go from 1 to 225. So another thing you can do as we're going here might be helpful. Our perfect squares are these ones that are multiplied by itself. 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5, and so on. These are also highlighted on your multiplication table that is on your desk. These are our perfect squares, and we're going to go up to 225 right there. So we know first that 1 times 1, oops, not yellow. 1 times 1 is 1 squared, so 1 squared is just 1. 2 squared, or 2 times 2 is 4. 3 squared, 3 times 3 is 9. 4 squared, 4 times 4 is 16. 5 squared, 5 times 5 is 25. 6 squared, 6 times 6 is 36. 7 squared, 7 times 7, we're not sure, we can look here. 7 times 7 is 49. That's where that yellow one is, called a perfect square. 8 times 8 is 64. Then we're going to go 9 times 9. 9 squared is 81. 10 squared, 10 times 10 is 100. 11 squared, this is where it gets tricky if you need to use your multiplication table. 11 squared is 121. 12 squared, same. It's going to give us 144. 12 times 12 is 144. 13 squared, 13 times 13 is 169. 14 times 14, right there, 196. And last, 15 squared, or 15 times 15, is going to give us 225. So these are called our perfect squares. But if we wanted to go the opposite direction, like earlier I said 3 times 3 gives us 9. If we know 9 is the area and we want to figure out what one of the sides is, well, we would take the square root, or the opposite of a square is going to be a square root. So the square root of 9 is going to give us 3. So over here, the square root of 9 is 3. So if I took the square root of 1, that would just be 1. The square root of 4 would be just 2. We're thinking what number multiplied by itself would give you 4. 2 times 2 is 4. Here, 3 times 3 is 9. So here, square root of 16 is really 4, because 4 times 4 is 16. Same here, square root of 25 is really just 5. I'm not going to list these all the way through, but you can see how they are related. These are the numbers we're going to be using today. So on our next slide here, we're going to first look at our rational numbers. These are numbers that make sense. Okay? What does this mean? It says this just means positive and the negative answer. We want both answers. So the square root of 36, well, right here, 36 and 6 go together, so the square root of 36 is just 6. So instead of writing plus 6 and minus 6, because they want both answers, we can just write plus or minus 6. This one we have negative square root of 4. Well, square root of 4 right here is really just 2. So our answer is negative 2. Then over here, 49. And if it helps you to look at your highlighted numbers here, 49, square root of 49 is 7. Same thing here, square root of 49 is 7. Down here, 121. 121, find that on your list. 121 is right here. So the square root of 121 would be 11. Square root of 100, this one hopefully you know, square root of 100 is just going to be 10, because, ooh, that was not straight. 10 times 10 is 100. And then last, 16. The square root of 16, what number multiplied by itself gives us 16? Well, 4 is. So just 4. Those are all nice rational numbers. They make sense. They're on our list of perfect squares. But now, on the next side, on the back, these are not perfect squares. 70 is not on our list here. 70, oh, nope, 64, we go right to 81. We don't go to 70. So what we're going to do is going to figure out between which two consecutive integers. What does that mean? Consecutive means that they are next to each other. And integers are just our, so I can't write, counting numbers. Counting by ones. Numbers by ones. That you'd see on your number line. So which two numbers are next to each other on our number line? Between which two? So they do not make sense, and these would be non-repeating decimals if we plug them into our calculator. We're not going to. We need to figure out between which two numbers is 70. Well, I just told you 70 is bigger than 64, but less than 81. So 70 is between 64 and 81. So it's really between the square root of 64 and the square root of 81. Well, we know the square root of 64, oops, too far, is just over here, 8. And the square root of 81 next to it would be 9. So your answer is between 8 and 9. So there's square root of 81 was 9. 103, we need to see between which two perfect squares is 103. It's not actually on our list, but it's really close to 100. It's actually a little bit bigger than 100 and less than 121. It's between those two. We're just looking, it's between these two numbers, only looking at the yellow ones here. So it's between 100 and 121. So it's between the square root of 100 and the square root of 121. So it's really between, well, the square root of 100 is 10, because 10 times 10 is 100. And the square root of 121 would be 11. So your answer is between 10 and 11. Next, the square root of 50. Well, let's find 50. 50 is really close to 49. It's a little bit bigger, so it's between 49 and 64. Square root of 49, square root of 64. Well, the square root of 49 right here is 7, and the square root of 64 is 8. So it's really between 7 and, oops, not 7, 7 and 8. A couple more. I would suggest trying these on your own and then checking your answer with me. So pause the video and try on your own. So I'm going to look for 18. 18 is between 16 and 25 right here. So let's write those two numbers down. Between the square root of 16 and the square root of 25. So the square root of 16 is really just 4, and the square root of 25 is really just 5. So it's between 4 and 5. And some of you might be thinking, well, 4 times 5 is an 18. That's not what we're looking for. We're not multiplying, because 6 times 3 is 18. That's not what we're looking for either. We're looking for between which two perfect squares is this number located. Okay? Because if we typed 18 in our calculator, square root of 18, we would get like 4.23578, whatever it gives us in our calculator. We just know that answer is between these two numbers. So let's find the square root of 37. 37, oh, really close to 36. So it's between 36 and 49. Square root of 36 is 6. And square root of 49, we did that one up here, it's just 7. So it's between 6 and 7. And our last one, this one's the same, it's just negative. So 11 is really close to 9, it's a little bit bigger. Bigger than 9, I'm sorry, less than 9, and it's between 9 and 16, 11 is. So it's between the square root of 9 and the square root of 16, but these both have to be negatives because we're just talking about the negative numbers. Well, the square root of 9 is just 3, so it's between negative 3 and negative 4. If that's confusing, make sure you come up to me and ask so I can explain this to you, what we're really looking for here. And the numbers that we're looking for, these square roots, these are called irrational numbers because it's between the two. It's not a nice number. Alright, next it says the top of a folding table is a square whose area is 200, oops, I made a mistake. There should be 121 square inches. Approximate the side length of the tabletop to the nearest inch. So I'm just going to draw a square here. We know the area is 121. We don't know what the side is. I'm just going to use the letter S to represent the side. We know that all of the sides are the same because this is a square. We know all sides of a square are the same. Well, remember back here, first slide, we said that 3 times 3 gave us 9. Well, if we have the area, like 9, and we want to figure out what the side is, we can do the opposite. Instead of squaring, we can do the square root. Like the square root of 9 is 3. So here, we know the area is 21, so our area is base times height, or side times side. Well, side times side is really going to give us side squared. Just like 3 times 3 gave us 3 squared, side times side gives us side squared. So we know our area, base times height, which is side squared, has to equal 121. And we just said if we wanted to figure out that side, we have to take the square root. Because really, a square root and a square are opposites. If this is way too much for you, I understand this is challenging. Just think we need to take the square root if we don't know and it's a square. Okay? Because the square root of 121 is just going to give us 121 right here. Square root of 121 is 11. So our side length, because those cancel out, a square root and a square are opposites, is just going to be 11. 11 is a nice number, so this is what we call a rational number. We'll talk more about rational and irrational numbers tomorrow. But last, we're just going to evaluate our exponents. 9 squared is really the same as 9 times 9, which is 81. If you're not sure, look back here. Oops. 9 times 9 is 81. And then we have 5 squared. 5 times 5 is 25. So 5 squared is 25. 7 times 7, 7 2 times. 7 times 7 is 49. And then last, 3 squared is really just 3 times 3, which is 9. If you have questions, please make sure to ask. Otherwise, you have a homework assignment. Good luck.